Hi, welcome to Expertisor Academy. This is Guru lecturer in physics. In this video, we discuss about the hysteresis. See the definition of first of all hysteresis. Hysteresis means lagging. Lagging means backward. So that is the number is very large. Okay. The lagging of intensity of magnetization behind the intensity of magnetic field. So this is the definition of the hysteresis. Now see this. How to change these two values? Explanation. A graph is drawn between the intensity of magnetization B and intensity of magnetic field H. This is the y-axis. This is the intensity of magnetization. This is x-axis. This is the intensity of magnetic field. This is the positive x. This is the negative x. This is the positive y. This is the negative y. See the first point here. When the intensity of magnetic field H is increased from zero, the intensity of magnetism is also increased. So what is the first point? When the intensity of magnetic field is increased from zero, okay, the intensity of magnetism or magnetization is also increased. Look at the point here. This is the point here. So here B is H is increased. H is increased automatically B also increased. Okay. Coming to the next point. Further increasing the value of H, the B value is also increasing. Further increasing of the H. H means intensity of magnetic field. The B value is also increasing. The B value is also increased. And finally reaches the saturation point here in the figure. It is B is constant. See this. This is the saturation point. Here, this is the point B. Okay. Next problem. Then decreasing the value of capital H, the B value is also decreasing. But at point H is equal to 0, but B is equal to 0. Now the material retains some amount of magnetism is known as retentivity of residual magnetism. Point B in the figure. See here, this is the point B. When decreasing the value of H, B value is also decreasing. Okay. But at point H is equal to 0, but B is equal to 0. Now the material retains some amount of magnetism is known as retentivity. So here the retaining point. This is the retentivity point B. And also it is the constant value. Next. Further decreasing the value of H in negative side. Further decreasing the value of in negative side. This one. The B value is also decreased at point C. The material is fully demagnetized. The force is required to remove the residual magnetism is called a coercive force. Okay, coercive force at point C in the figure. So this is the point C. So here coercive force is created and also this material demagnetized. Coming to the fifth point, the cycle is continue in opposite direction as shown in the figure D. As shown in the figure D. So this is the point D. In saturation point, E is retentivity and F is the coercive force in negative direction. So this is the E. This point E indicates the retentivity in negative direction and F indicates the coercive force in the negative direction. Okay. The cycle is completed. It makes the hysteresis loop. This makes the hysteresis loop. Okay. See once again these points. So what is the point one saying? Intensity of H, that means magnetic field increase from zero. The intensity of magnetism is also increased at point A. This is the saturation. Next, coming to next. Further increasing the value of H, the B value is also increased and finally reaches the saturation point here in the figure. It is B is constant. That means at first H is increased, automatically B also increase, it reaches point A. The further increase in H, there is no increase in B. That is the saturation point. Initial point is A, and also A is the saturation. That means B is constant. B is constant. Okay. Next, then decreasing the value of H. The B value is also decreased. But at the H is equal to 0, B is equal to 0. Now the material retains some amount of magnetism known as retentivity or residual magnetism, point B in the figure. So this is the retentivity or residual magnetism when H is equal to 0. Okay. Further decreasing the value of H in the negative side. The B value is also decreasing at point C. The material is fully demagnetized. The material is fully demagnetized. The force is required for removing the residual magnetism is also called as coercive force. Magnetism is called as coercive force at point C. At point C, that is coercive force. Last one. The cycles continue in the opposite direction as shown in the figure. D is saturation point, E is retentivity, and F is coercive force in negative direction. D is saturation. It is similar to A but in opposite sign. That is negative sign. Next, E is retentivity. E is retentivity, which is opposite to B. Next, F is coercive force in negative direction. Okay, so this is the F, which is opposite to C. So this is the total cycle of hysteresis law. See the hysteresis explained by the domain theory. OA. This is the origin. This is the A. That represents reversible domain. O to A. That is the C here. O to A. That is reversible domain. AB. Irreversible domain. AB. Irreversible domain. BC. Domain rotation. BC. Domain rotation. BR. Retentivity. BR. So it's not a actually BR. That is, there is the symbol of the here. BH. That is the BH. That is the retentivity. HC. Where is the H? Here this. This is the H. This is the H. HC. That is cursivity. Okay. This is the domain T. Energy product. See the energy product here. BR into HC. BR into HC. That means retentivity. So here BR means that is a relative magnetization or BH. That means the distance from this point to this point. That is retentivity. So BR into H. So this is the hysteresis. Next, applications. There are great variety of applications of the hysteresis in ferromagnets. Many of these make use of their ability to retain a memory. For example, magnetic tape or disk and freight parts. In these applications, hard magnets, high porosity like iron or dissolvable soda, memory is not easily erased. Soft magnets, low porosity, are used as force in electromagnets. The nonlinear response of the magnetic moment to a magnetic field boosts the response of file wrapped around it. The low porosity reduces the energy loss associated with it. Okay, hysteresis. Here, soft magnets, low porosity, used in electromagnets. Next, in Neuroscience, some neurons do not return to their muscle conditions from a stimulated condition immediately after removal of the stimulus in examples of hysteresis. So these are the applications of the hysteresis. So this is the concept of hysteresis. Thanks for watching this video. For more videos, visit www.expertisoracademy.com.